Okay, let's go to the next whiteboard and optimize this tabulation solution. And let me, same as did the previous slide, let me duplicate this guy. And here I have the previous answer. I can erase all of these guys. I want to have more space to. We detected that we need only 2 rows. We can handle all of this problem with 2 rows only. And let me raise all of these guys. And this part. Also all of these, explanations to make it a little cleaner. I want to move these guys up. Okay. And that's it. And now I can zoom in all of the code to be able to work on this code. Okay. Let's go. I think it is better to... Yeah, okay. So, as I said, we need 2 rows. So, what is the first step? First step is to change the DP matrix dimension. And I will erase this guy because this is the number of rows. And I will write here with the, let's say, which color is better? Yeah, I think the green is better. 2. We need only 2 rows. So it is like we have for the previous example, this is our I will be only 0 and 1, J will be 0, 1, 2, 3, 4. And so this is the first step, updating the DP dimension. And the next step, which is last step in most problems, but this problem is a little difficult. We have 3 steps, but that's why I want to do first the easy part, which works for most problems. But here we will do one extra step, and I will show you what's that. Okay, so the next step, you don't need to change the for loops without any change, right? Keep them as they are, because we have to do T times P operations. We don't want to change it. But when we want to access to the DP matrix, I can only be 0 or 1. So whenever we access the DP with I index, we should write I modulo 2, right? I remainder 2 for when we access the DP. So that's why I want to change all of the DPs that we have I. So I will change this guy to DP. Let me write with the same color. It was J, right? So, but this guy will be I plus I modulo 2. Same we have here will be DP of I remainder 2. And here also we have same scenario. It was I, right? It was, I forget it was I. Let's DP of I remainder 2, and also we need to change this guy, and it's done. Let me change these here. Will be I plus 1, remainder 2, and what was the J? It was J, no, not J plus 1, it was J, okay? And for the last part, we have same scenario. I should remember it was J plus 1, so it is I plus 1, remainder 2, and J plus 1. As you can see, we didn't change the length of J, right? The number of columns. We don't need to change J. We don't need to change for loops. Only you need to change these guys. We did, let me do the same color to emphasize what is the change actually. For all of the I, all of the indices for I should be changed to remainder 2, and that's it. But there is one important point here, which is the initialization. If do you remember, we said we have to have for the last row we have to have true, but for all rows except last row in the DP, we have to have false. Right now we don't have any control on these values. Although we are doing this as true, but when we calculate the next row, in the next rounds we don't have any control on the last column. So it means that for every row we have to calculate, actually update the last column of each row. So how we can do that? Actually, let me move all of these guys down. Let me erase this line. Okay. And also I want to remove this. I need a little more space on top to be able to add some conditions. The order for loops are not important. You can put for I on top or J on top. It doesn't matter. We want to populate all of these guys, right? So right now we will say if we are in the last row, and if we are in last row, we have to update the last column with true. But if it is not last row, we have to update the last column with false. I think it's better to change the direction, the order of these guys to handle this part a little easier actually. As I said, it is not important the order of these for loops. The only thing which is important is the range of the loops. I want to do this to make it a little easier. Let's say we have for I, J, but for each row we want to check if it is the last row. We want to update the initial values. So let me bring this down. I need more space here because for each row I want to do some check some conditions. Push this on top. Okay, so I will say if I is equal to len of text. It means that we are in the last row. We have to make the last column true. So I will write dp of I. Because we have only 2 rows, whenever you have index of I, you have to do the I remainder 2. And the last column, or I can write a -1, will be true. What else? If it is not the last row, we have to make it false. And that's it. In most tabulation solutions, in the optimization part, usually we don't have this this part. If you simply change all of the indices, it's done, because in most of the in most of DP problems, the initialization are in the only is easier than the initialization part we have for this regex problem. But even if you have a little complicated, nothing will be changed. You need to have only some base, the initialization part. In most cases, we do this before, like we did here. We do this before the for loops. But in this case, for this problem, we need to do the initialization for each row. That's why you can, even, raise this guy, because we do this for every row. You don't need to do that. But as I said, I want to repeat this because it is really important. In most DP problems, if you want to optimize the tabulation solution in terms of space complexity, all you need to do is to change all of these i's, the indices, remainder over 2 if you have 2 rows. In some cases, initialization is a little tricky. You need to do for each row, but in most cases you can do simply before nested loops. But for this problem, you need to do this exactly for each row. So as you can see, for this problem, time complexity is same as the previous solution, which is order of t times p, because we have 2 for loops for len of text and len of pattern, which is we have t times p iterations, but the space complexity decreased to 2 times p, which will be p. And this is the last part of the session. I hope you enjoyed it, and if you have any question, you can ask in meetup page in the comments part. And I hope you enjoyed it. And I think this is one of the really hard problems. If you learn one of these kind of problems in a perfect way and in a correct way, in an optimal way, the difficulty of the DP problems will be eased for you. It will be really easy for you guys solving the DP problems. Thank you, and see you next week. And I will go over maybe some more DP problems, or I will go through some other patterns like DFS or BFS and backtracking problems. See you guys next week.